Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. We've seen the intuition, the diagram, and the algebra behind the Frisch-Waldo-Well theorem. Now let's verify it with real data in R. We'll use the H-priced one dataset from Woolridge, which has 88 house sales in Boston in 1990. So without further ado, let's switch to R for that. You can access again as any other video where we have done our ORTS data coding, the code on our website. We're going to use library Wooldridge and ggplot2 because we're going to do a nice visualization of the graph as well in terms of what is happening behind the visualization process. So let's look at the data H price 1 very quickly, what it should give us. So as you can see here, we've got the price, we've got the surface area of the room in square feet, and then the number of bedrooms as well. The price, again, here is in thousands of dollars. So keep that in mind if you are using the results from this video to also practice on coefficient interpretations. If we look at the correlation very quickly, just to have an idea of like, what should we see in terms of like betas as negative, positive, or should we expect there to be big betas or not? The correlation table is the following in here between, in any case, the surface area and the number of bedrooms, 0.531. This is a positive correlation, and we can see that it's quite strong. In any case, it's almost halfway through to a correlation of 1. So in any case, we should be expecting to see positive coefficients when we run our regression in terms of the relation between surface area and the number of bedrooms in any case. If you remember, for the visualization, we went through quite a few steps. But before we do all of the steps, let's look at what does the full model look like. So in the full model, what we're going to look into is a regression of price on the surface area and the number of bedrooms. We expected for there to be positive coefficients, and as we can see the area here, the beta is actually positive. It is also statistically significant, which means that when the surface area of a house increases, so does the price. And the same happens also for the number of bedrooms, although that is statistically insignificant in here. So we could say that increasing the number of bedrooms actually does not change the price. If you think about it intuitively, since in this case we have a multiple regression, if we are holding the surface area constant, actually increasing the number of bedrooms might not really be such a good thing for the price, because it means that every bedroom now is a lot smaller, so less use for smaller bedrooms. But in any case, the whole point behind this is not really interpreting the model, but it's just looking at like what is happening in this full model, and let's see how does the visualization give us exactly the same result. So if we were to memorize from here and to get away which is the beta that we are mostly interested in, keep in mind is the one that we had in front of the surface area, which is 0.13 approximately. The first step of the residualization would have been to residualize x1, which is the surface area on the number of bedrooms. And this regression in here would have given us an intercept in here of 364 approximately. Okay. From here, keep in mind that we need to residualize x1, right? So we need to take the x1 tilde that does not have the influence of x2, which in our case is the number of bedrooms. That's why we're going to save the residuals by using of course, the residuals formula on R. So once we save the residuals as an actual variable, we can also see like more information on how do the residuals look like. Like these are some of the values that we see. We can also do a plot of the square feet variable and bedrooms variable just to see like what exactly do we expect as a out of this regression. And as you can see, this is a positive relationship because the higher the number of bedrooms, the higher also the size of the house overall will have to be. Okay. Keep in mind, all over again, the whole point in here of getting the residualized x tilde was, or x1 tilde was just because we want the part of size of the house that is unrelated to bedrooms. For the second step, we had to residualize y. So in this case, we're going to run a regression of price on the number of bedrooms and again, get the residuals out of that regression because that is what's going to give us the y part that is uncorrelated to the number of bedrooms. We can do exactly the same thing to see like what does the relationship look like and to see some of the values of the residuals out of this regression. And as you can see here, this is not as steep as the previous one, and the y tilde would have taken the part of price that is now unrelated to the number of bedrooms. The last step would have been to regress the y tilde on the x tilde. Now, if you remember, in the very first regression, we had that the beta was the 0.13 approximately. So more precisely, it was 0.1284. So now if we use exactly the price tilde and the square feet tilde, we should be able to see exactly that same number or approximately that same number. And as you can see in here, this is a very, very small number that we're seeing. We can compare and actually just fetch this coefficient even more clearly in here. So it is exactly the 0.1284 that we had found in the previous one. Okay, so keep in mind here you're seeing 1.284, but don't worry because as you can see, you've got also e to the power 0.1, so it means that this actual number needs to be divided by 10 so that you can get the actual coefficient. That's why ultimately you see 0.1284, which is exactly what you had before. Okay. Remember, orthogonality, you can also plot actually the residual on residual, which is basically the key graph in your Frijol-Lowell theorem overall. So let's do that to see. The slope that we see in here is basically based on the regression that we have done on x tilde and the y tilde. So ultimately, this should have been exactly the same sort of relationship that we would have seen if we had grabbed the full model at the beginning as well. And you can do that by either plotting side by side the full regression model so you can see the beta one, or the other way that I have chosen in here is just to actually have a table with all of the numbers in here so that we can see exactly whether they are the same or not. And as you can see from the first model, we have the 0.1284, which is the same as the second number, which means that they are equal, and we've also got like a little bit of the interpretation, which is just one additional square foot increases the price by approximately $128, holding the number of bedrooms constant. Okay, so this is quite straightforward and easy, and you can replicate this code with any data set that you wish to. Ultimately, what you have to take away from here is that whether you are using the full model or you're using the residualized version, the coefficient ultimately in both regressions is going to be exactly the same. I hope this was helpful, and I'll see you in the next video.